We've been studying Newton's laws of motion for quite some time now. I think it's time for us to do a quick review and to go forward and see if we can actually apply some of our knowledge that we've had so far. We've had some quizzes, we've had a test, and now it's time to have a little challenge. Newton's first law states an object at rest or in motion stays at rest or in motion unless acted upon by an unbalanced force. That means the sum of the forces would have to equal something other than zero. Okay, so what does this mean? Remember in class when I did the demonstration where I rolled the bowling ball and I said, okay, we have an applied force and it's going to roll along the floor, and once I kick it with my foot and I give it a force to go forward, it will roll forward. It should continue rolling forward forever and ever. But that isn't what happened. Instead, the bowling ball rolled forward and eventually came to a stop farther ahead. Why did the bowling ball stop? Was there another force acting on it? Sure. We did enough free body diagrams to figure out that we have gravity, normal force, and once my foot no longer was in contact with that bowling ball, right, that applied force is gone, what caused the bowling ball to slow down and stop? That evil force, frictional force. So that's what causes our bowling ball to eventually slow down and stop. If we could get rid of the frictional force, if we could somehow remove that from the picture, then it appears that we just have our normal force up, our weight down, and there's nothing to slow it down or speed it up in either direction. So our bowling ball should continue moving forward forever and ever. Once we mastered the free body diagram and drawing all our forces and learning about tension, gravity, weight, the difference between mass and weight, and all of our other forces such as buoyancy and air resistance, we decided that it was time to move on to our favorite, F equals ma. And technically, right, this should be F net, the net force. So again, the sum of all of the forces acting on the object. If the sum of the forces equals a non-zero number, that object will accelerate. And also we spoke about looking at the relationships between acceleration and mass and acceleration and force. And we said that acceleration and mass have an inverse relationship, whereas acceleration and force are directly related. And this should make some sense, I think, by now. If you push on an object with a greater force, it will accelerate at a greater rate. If you push on an object that has a mass of 2 kilograms and a mass of 20 kilograms with the same force, obviously we know that the object that has the greater mass will have a smaller acceleration. This brings us to Newton's third law. Every action force has an equal and opposite reaction force. And it's baseball season. So here we have our baseball bat and our lovely baseball. And go Cubs! If we were to swing and hit the ball we would have an action force of bat on ball, our action force, and then we would have a reaction force of the ball on bat. We'll label that as reaction. And these forces would be equal and opposite. So what's the story here? Why does the ball wind up going and the bat, hopefully, is just dropped down? Why does the ball have a greater acceleration? Well, this is where the laws are all interrelated and kind of come together. So the force of the ball on the bat equals the force of the bat on the ball. F equals ma. Okay, but we see they have different accelerations. So if we use blue for the bat and red for the ball. Okay, so we have acceleration equals F over m, and acceleration equals F over m. The equation stands true regardless. They're both going to accelerate, just at different rates. So now we see that our forces are equal and opposite, so I'll leave my force the same size. What do we know about the mass of a baseball? Is that a large mass or a small mass? We would say, hopefully, it is a small mass. So let's put a nice little tiny m there. And the mass of the bat relative to the baseball would be very large. So what does this do to the acceleration of the bat and the acceleration of the ball? Well, the acceleration of the ball, since it's a little mass divided by a force, it's an inverse relationship from our previous page, so it would have a big acceleration. Our bat, since it has a large mass, and again it's an inverse relationship with acceleration, that would have a tiny acceleration. Also, if we say the bat is going forward, then the ball is going backward, and or vice versa. So you're asking yourself, what does this have to do with me? Well, physics is no fun if we don't actually get to do anything with it. And I thought to wrap up this unit, we would have a little challenge. And our challenge will be to create a balloon rocket. And in your module on this Clogster as well, you will see that I have a worksheet for you to work through with your group. And what you're going to do is you are going to construct a balloon rocket with the given materials. And each desk will have a set of materials, and each group will only have that set of materials. So your challenge is to create a balloon rocket out of those materials that will go the farthest horizontal distance. And you may have noticed when you walked into the room today that there's stools hanging up and things kind of pushed to the side. And so the object is to get it to go the farthest distance across the room. And of course, I like to have all kinds of rules and things to kind of keep it fair. So you can practice as many times as you like, but you will only get one set of materials. So try not to destroy your straw or pop your balloons or rip them with the tape or any other disastrous things. You can have 2 or 3 trials depending on how many you would like to do, but they only count when I am watching. So you will need to call my attention. and I will come over and watch. And I will record your greatest distance traveled. As always, a prize goes to the victor. So hopefully your group will be successful. You'll go the greatest distance and complete your write-up and submit it to me by the end of the class period today. Good luck. Launch away.